Welcome to the DIY Honda Garage channel. The DTC P0121 refers to a condition where the throttle position TP sensor A is perceived to be out of its operational range. This is part of the Powertrain Control Module (PCM) diagnostic system in Honda vehicles, particularly in models like the CRV from 2017 to 2022. The throttle position sensor monitors the position of the throttle valve, which regulates airflow into the engine and is crucial for efficient engine performance. When this sensor's readings fall below a certain threshold, the PCM may trigger the P0121 code to indicate a problem. The context of out of range suggests either an electrical issue with the signal received or a mechanical fault with the throttle component itself. If repairs are needed, understanding the verification process and how to address potential issues is key. The throttle position sensor A is specifically designed to monitor the angle of the throttle valve within the throttle body. This sensor plays a critical role in determining the engine's air intake and directly affects engine performance and fuel efficiency. It is usually integrated into the throttle body assembly, which controls how much air enters the engine based on the driver's acceleration input. As the throttle opens or closes, the sensor outputs varying voltage signals to the PCM, which interprets these changes to adjust fuel injection and ignition timing accordingly. The typical operational voltage range for this sensor is between 0.39 volts and 4.5 volts, with values outside this range indicating potential issues. Thus, a reading that triggers a P0121 indicates that the PCM is unable to receive a valid signal from the sensor, leading to possible performance issues or increased emissions. Several potential causes could lead to the triggering of the P0121 DTC in your Honda CRV. One major cause could be a faulty throttle position TP sensor A itself, which may be failing to provide accurate voltage signals to the PCM due to internal defects. Another possibility is wiring issues, which can stem from frayed wires, poor connections, or corrosion that interrupts the electrical signals between the sensor and PCM. Loose terminals at the connectors can also lead to intermittent signal loss and should be inspected thoroughly to ensure a solid connection. Additionally, problems within the throttle body itself, such as mechanical binding or sticking, can give erroneous signals to the PCM and result in the code being triggered. Therefore, systematically examining these components is essential to accurately diagnose and rectify the problem. When the DTC P0121 is active, several symptoms may manifest, all indicating a disrupted connection between the throttle position sensor and the engine's control system. One primary symptom is reduced engine performance, as the engine may struggle to respond adequately to throttle inputs. This can lead to an unresponsive throttle where pressing the gas pedal does not yield the expected acceleration, leaving the driver with a frustrating and potentially unsafe driving experience. Furthermore, because the throttle position directly impacts the air-fuel mixture, increased emissions may also result from the incorrect fuel delivery. As a result of these problematic conditions, a check engine light on the dashboard will likely illuminate, signaling the need for immediate diagnostic investigation to avoid more severe mechanical issues down the road. To begin troubleshooting DTC P0121, the first step is to verify the vehicle's problem status. Start by turning the vehicle to the on position without starting the engine. This enables the onboard diagnostic system. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs from the system. Once cleared, monitor the throttle position sensor A using the HDS to check its current voltage output. you want to see if the sensor's readings fall below 0.39 volts. All voltage conditions should be recorded. If the readings consistently align with the threshold, then the malfunction appears to be a confirmed issue, and we should proceed to the next troubleshooting step. It's crucial to document any findings during this stage for future reference. In Step 2 of the troubleshooting process for DTC P0121, we'll repeat the voltage test on the Throttle Position Sensor A. This time, check for voltage readings that exceed the maximum threshold of 4.5 volts. If the output from the TP sensor A does exceed this limit, we have a confirmed failure, and the troubleshooting guide instructs us to proceed directly to Step 7 for further investigation. However, if the sensor's voltage does not exceed this value, it may indicate that the issue is intermittent, suggesting that the system could be functioning correctly at this moment. In this case, closely inspect for any poor connections or loose terminals between the throttle body and the PCM to ensure reliable and accurate signal transmission. Return to the previous snapshots taken for further guidance if available. Step 3 involves determining the failure area by using the HDS to check for any additional pending or confirmed diagnostic trouble codes, DTCs, present in the system. This will help identify if other faults exist alongside P0121. Specifically, you want to look for DTC P0221, which indicates a problem with Throttle Position Sensor B. If both DTC P0121 and P0221 appear together, this could point to a broader issue with the throttle system rather than a localized failure. In this scenario, follow the instructions provided and transition to Step 5. Alternatively, if DTC P0221 is not indicated, you can continue troubleshooting through Step 4 to isolate the issue further. Step 4 requires us to execute a shorted wire check on the THL1 line. Start by turning the vehicle off to ensure safety during testing. Next, connect a shorting connector to the SCS line using the HDS, waiting for a full minute to stabilize the system. After this period, carefully disconnect the relevant connectors, namely the PCM connector B, 51P, and the throttle body 6P connector. Now, it's time to check for continuity between designated test points. The throttle body 6P connector's female terminal number 6 and the body ground. If continuity is detected, it would imply that there is a short in the THL1 wire, requiring immediate repair. However, if no continuity exists, this indicates that the THL1 wire is in good condition. From this point, it's essential to consult authorized service information for additional guidance, or you may consider substituting with a known good PCM to eliminate it as a cause. In Step 5, we focus on assessing the throttle body to identify any faults. Begin by turning the vehicle to the off lock mode and disconnecting the throttle body 6P connector. With the connector detached, switch the vehicle back to the on mode to allow for testing voltages. At this stage, measure the voltage between test points 1 and 2, specifically the female terminal, number 5 of the throttle body 6P connector, and a solid body ground. The accompanying expectation is that you should find a voltage reading close to about 5.0 volts. If this is the case, it strongly indicates that the throttle body is faulty and requires replacement. In contrast, should the voltage not align with this expectation, then further investigation through subsequent troubleshooting steps is necessary for accurate diagnosis. Moving to Step 6, we perform an open wire check on the VCC3 line. Begin by turning the vehicle off lock mode for safety. Again, utilize the HDS to jump the SCS line, allowing for a short wait of more than a minute for the system to stabilize. Disconnect the PCM connector B, 51P, to prepare for continuity testing. With both the throttle body 6P connector and the PCM connector disconnected, check continuity between the throttle body 6P connector's terminal number 5 and the PCM connector B, terminal number 48. If continuity exists, this indicates that the VCC3 wire is functioning properly. However, a lack of continuity suggests an open in the VCC3 wire, necessitating repair to restore proper signal transmission between components. At this stage, being step 7, we are re-evaluating potential failure areas, particularly related to the SG3 line. Utilize the HDS once more to check for any confirmed or pending DTCs. As in previous steps, the focus here is again on the appearance of both DTC P0121 and P0221 together. If these codes are recorded simultaneously, it may indicate a systemic issue requiring more comprehensive diagnostic procedures. In this situation, the guide directs you to step 10. Conversely, should P0221 not appear, you will proceed to step 8 to explore other possible areas contributing to the sensed failure in the throttle position sensor system. In step 8, we head back to the throttle body for further testing. Start by turning the vehicle to the off-lock mode and disconnecting the throttle body 6P connector. Now switch the vehicle to the on mode again to check the voltage output from the throttle body. In this context, you will measure the voltage between test point 1, which is the female terminal number 6 of the throttle body 6P connector, and body ground. The expectation for this check is to find a voltage reading around 5.0 volts. If the reading confirms this desired voltage, it's an indication that the throttle body is at fault and will need replacing. If not, further diagnostics are warranted, leading to troubleshooting steps that will target any underlying issues. In this step, which is step 9, we conduct an open wire check specifically focusing on the THL1 line. Make sure to turn the vehicle to the off-lock mode to ensure safety during testing. Once the vehicle is off, jump the SCS line with the HDS, waiting for over a minute to allow the system to stabilize. Disconnect the PCM connector B51P for the next phase of the test. At this point, with both the throttle body 6P connector and the PCM connector B disconnected, check for continuity between the female terminal number 6 of the throttle body connector and PCM connector B's terminal number 46. If continuity is confirmed, it indicates the THL1 wire is fine and functioning as intended. However, if continuity fails, this suggests an open in the wire, thereby necessitating immediate repair to ensure proper operation. In the final step of troubleshooting for DTC P0121, known as Step 10, we will conduct an open wire check on the SG3 line. Just as before, begin by ensuring the vehicle is turned off-lock mode for safety during testing. Utilize the HDS to jump the SCS line for over a minute to stabilize the system, after which you will disconnect the PCM connector B, 51P, and the throttle body 6P connector. Next, check continuity between the throttle body 6P connector's female terminal number 3 and PCM connector B's terminal number 49, ensuring both connectors are disconnected prior. A successful continuity check indicates that the SG3 wire is functioning properly, while failure necessitates looking into and repairing the open in the SG3 wire, which connects the throttle body to the engine control module. Following the completion of all relevant troubleshooting and repairs for DTC P0121, the next imperative step is to verify that all repairs have been executed correctly and effectively. Use the Honda Diagnostic System, HDS, to clear the DTCs from the onboard computer, ensuring that no residual codes remain. After clearing the DTCs, Road test the vehicle to replicate various driving conditions. During this test drive, pay close attention to throttle response and variations in performance to verify that the throttle body and sensor are now functioning as intended. During the road test, check that the DTC P0121 does not reappear on the HDS diagnostic screen, confirming that the repairs have rectified the noted issue. If the DTC does return, further evaluation of the wiring and connections may be necessary. To prevent the recurrence of DTC P0121 and similar issues in the future, implementing a routine preventive maintenance schedule is highly recommended. Regularly checking the throttle system for physical or mechanical wear can help catch problems before they lead to fault codes. It's also essential to conduct inspections on the wiring harnesses and connectors associated with the throttle body and TP sensors, looking for signs of corrosion, wear, or damage. Furthermore, keeping the engine control software up to date can assist in minimizing the risk of software-related faults, enhancing overall system reliability. By taking these preventive measures, you can help ensure that the vehicle maintains optimal performance, thereby preventing costly repairs down the road. In conclusion, the DTC P0121 serves as a vital indicator of potential issues related to the Throttle Position Sensor A within your Honda CRV. The effective troubleshooting steps provided allow technicians to systematically diagnose the problem, ensuring reliable repairs. Key steps include conducting thorough voltage checks, continuity tests, and assessing the health of the throttle body. Further, adherence to preventive maintenance can significantly reduce the likelihood of future occurrences of this DTC or similar faults. By remaining vigilant regarding the throttle system's condition, one can maintain performance integrity and ensure an overall smooth driving experience in the Honda CRV. Regular diagnostics and timely repairs will ultimately contribute to vehicle longevity and reliability. Please like and subscribe to the channel. See you next time.